Good evening, everyone.
Good
Good
evening,
evening,
sir.
sir.
So we'll wait another 5 minutes, then we'll start. Let us hope
Yes,
that
sir.
some more friends will join, then we'll start.
Okay, sir.
Yeah. Okay, friends. So today we'll start with block 2. Block 2 is about the climatology and meteorology. In this block, there are again 4 units. So yesterday we finished unit 1, 2, 3, 4. So today we'll start with unit 5, 6, 7, and 8. Unit 5 deals with the elements of climate, details on climate control, the earth radiation balance, latitudinal and seasonal variation of insolation, temperature, global pressure and wind belt, and humidity are given. Cloud formation and precipitation, water balance, spatial and temporal patterns of climate parameters are also explained with diagram for easy understanding. Unit 6 deals with the weather phenomena, detail on air masses and fronts, southwest and northwest monsoon, jet stream, tropical and extratropical cyclone, ENSO and QBO have been explained. Finally, the unit focuses on the Koppens and Thoron scheme relating to the classification of climate. Unit 7 deals with the meteorology, thermal structure of the atmosphere and its composition, pressure, temperature, wind, humidity, moisture, variable virtual temperature, radiation from sun, solar constant, surface and planetary albedo, emission and absorption of terrestrial radiation, radiation windows, greenhouse effect, net radiation budget, atmospheric stability diagram, turbulence, diffusion, dry and moist air parcel, thermodynamic diagram, T diagram and mixing height, thermodynamic of dry and moist air, specific gas constant, adiabatic and isoentropic processes, entropy and enthalpy, adiabatic process of moist air. Unit 8 deals with the hydrometeorology and climate, hydrometric network and catchment morphology, precipitation, evaporation, and transpiration, soil moisture, river flow, river, lake, and groundwater, occurrence of surface water and groundwater, movement of water on the surface and below the surface. Overall, this block in the core course, Earth processes, will equip you well with knowledge on the various aspects of climatology and meteorology. So, in this block, you will learn about climatology and meteorology. In this unit, you will be introduced to element and control of climate. You know that sun is the prime source of energy for earth and the differential heating of earth by sun spatially and temporally results into difference in the climatic elements which leads to different climatic patterns. However, there is a balance between incoming solar radiation and outgoing radiation from earth which you will learn later in this unit. You will study about latitudinal and seasonal variation of insolation pressure is another important element of climate. If you look at the globe, there happens to be alternate arrangement of high and low pressure belt induced not only by thermal factor but also dynamic factor related to the earth rotation. Difference in pressure gives rise to wind. We will also discuss about humidity, which is another element of climate and an important determinant of precipitation. Precipitation is uneven, and so is the distribution of water around the globe in different reclam and at different times. Thus, the knowledge of water balance is essential, which will be discussed in the unit. Lastly, you will also get acquainted with spatial and temporal patterns of climate parameters. Elements and controls of climate. Before we study elements and control of climate, let us first know about weather and climate. Though these terms might sound similar, but the term weather is used to describe the condition of atmosphere at a certain place at a specific time, while climate is the average of atmospheric condition of an area over a considerable time, say for about 35 years. Weather denotes day to day or even hour to hour phenomena on a large or even a small area. It is subjected to drastic changes at any time. On the other hand, climate involves systematic observation, recording, and processing of the various elements of the climate, such as temperature, pressure, wind, humidity, rainfall, etc. It is also controlled by other elements such as altitude, distribution of land and water, mountain barrier, global pressure belt, air masses, atmospheric disturbances, and ocean currents. Now let us learn about the term climatology and meteorology. Climatology is the study of atmospheric condition of different part of the earth over a long temporal duration. Meteorology is concerned with day-to-day atmospheric condition and their causes. Meteorology and climatology represent the study of weather and climate respectively. The different essential being the different time scale and approaches used for such study. Meteorologists tend to concern themselves with the analysis of actual weather situation, while climatologists are more concerned with the aggregation of such situation. Earth radiation balance. Sun is the prime source of Earth for energy for Earth. It heats up the atmosphere and Earth through insolation, which is the incoming solar radiation. However, Earth intercepts only a minute percent of the solar radiation, which is only about a very small amount, 1 in 2 billion part of sun's energy output. Also, it takes 8 minutes 20 seconds for sun's energy to reach the earth's surface. The amount of solar radiation intercepted by the earth's surface is approximately 2 calories per square centimeter per minute, or 2 Langley. Langley is known as the solar constant. There are various processes responsible for the movement of this heat energy and heating and cooling of the atmosphere, like radiation, reflection, scattering, absorption, transmission, conduction, and convention. It is also important that there exists a perfect balance between the amount of incoming solar radiation and the outgoing terrestrial radiation. If the outgoing radiation had not occurred, the surface would have become progressively hotter. The balance between the amount of insolation and outgoing terrestrial radiation is known as the Earth's radiation balance or Earth's heat budget. Now let us study how it happens. Of the total 100 unit of solar radiation reaching the Earth's outer atmosphere, 34 units are directly returned to space without attempting to heat the atmosphere. Of these 34 units, 25 units are reflected by clouds to space. 2 units are reflected by Earth's albedo, and 7 units is also lost as a result of scattering by air molecule and dust particle in the atmosphere. Of the remaining 66 units, 19 units are absorbed within the atmosphere, 16 units by gases, and 3 units by clouds. The remaining 47 units reaches the Earth's surface, which is actually converted to heat energy, out of which 19 units are received at the Earth's surface as direct sunlight. 23 units are diffuse radiation through clouds and 5 units as scatter radiation. Thus, a total of 66 unit, 19 unit plus 47 unit of the effective solar radiation is actually absorbed by atmosphere and Earth's land sea surface. It is effective in heating up the Earth's atmosphere. In order to maintain the terrestrial heat balance, the 66 unit of solar radiation gained must be balanced by the same amount of energy radiated back to space in the form of long wave terrestrial radiation. Let us see the operation of the terrestrial heat balance. The Earth radiates 120 unit of energy upward, out of which 6 units are radiated back to space directly. The atmosphere absorbs the remaining 114 unit of long wave Earth radiation. Further, 10 unit of heat are transported upward by convection current. Thus, the atmosphere gains these 10 unit of heat. The atmosphere also gains 23 unit as latent heat carried to its in the hydrological cycle due to the process of evaporation, condensation, precipitation. 19 units of solar energy were already absorbed directly by the atmosphere as discussed above. Hence, the total unit absorbed by the atmosphere is equal to 166. Out of the 166 unit, 106 unit are re-radiated back to the Earth's surface and 60 are radiated back to space. These 60 units, in addition with the 6 units radiated directly by the Earth's surface, brings the total 66 unit of energy which is actually radiated back to the space. Thus, the amount of incoming solar radiation is balanced by an equal amount of outgoing radiation. Here is the diagram which shows the heat budget of the atmosphere and Earth. So, in the left hand side, the incoming short wave solar radiation, whereas the right hand side, the outgoing long wave Earth radiation. They have shown it here. Then latitudinal and seasonal variation in insolation. There are spatial and temporal variation in the amount of insolation received. Tropical zone between 23.5 degree north and 23.5 degree south receive the maximum insolation. All places in this zone receive overhead sun twice a year because of the apparent movement of sun northwards and southwards. The middle latitude zone extending between 23.5 degree and 66 degree in both the hemisphere receives maximum insolation at the time of summer solstice, that is 21st June in the northern hemisphere, and in the time of winter solstice, that is 22nd December in southern hemisphere. They receive minimum insolation at the time of ventral equinox, that is 21st March in northern hemisphere, and autumnal equinox 23rd September in southern hemisphere. The polar zone extending between 66 degree and 90 degree in both the hemisphere receive maximum and minimum insolation at one time in a year. Here sometime the insolation becomes zero due to the complete absence of solar rays. The distribution of temperature across the latitude is known as horizontal distribution of temperature. Isotherms show the horizontal distribution of temperature on Earth. The term isotherm is derived from the two Greek words isos meaning equal and thermos meaning hottest. So isotherms are imaginary lines drawn on a map connecting places having the same temperature reduced to mean sea level. The most important isotherms are the mean monthly isotherms, especially for the month of January and July. As these months have the greatest extremes of temperature owing to the apparent movement of the sun, the isotherms of this month are important. Then the global pressure and wind belts. You might have studied at previous level that air is a mixture of several gases. So air has weight of its own and is able to exert pressure through this weight. Air pressure can be defined as total weight of mass of column of air above per unit area at sea level. Pressure on 1 square centimeter area of the surface of Earth would be equal to the actual weight of the column of air above that area extending upward to the outer limit of the atmosphere. So, atmospheric pressure is the force per unit area exerted by a weight of the air above it. As air is compressible, so the air which lies in the lowest portion is greatly compressed and is therefore the densest, whereas as we move up, both density and pressure of air decreases. The air exerts a pressure of 1034 gram per centimeter square at sea level. As one goes up from the sea level to higher altitude, air pressure decreases. You might have experienced mountain sickness in the form of a nose bleeding, ear bleeding, nausea while traveling to places of high altitude. Mountaineers face this difficulty because the higher we go, the thinner the atmosphere becomes and there is lesser pressure and hence lesser oxygen. Bleeding of nose and similar ailment are related to the higher pressure inside the body compared to the lower external pressure due to which the thin nasal capillaries tend to bleed. The instrument to measure the atmospheric pressure is called barometer. It is a glass tube 1 meter long which is sealed at one end and completely filled with mercury. The open end is inverted and immersed into a dish of mercury. Under normal atmospheric condition, the mercury in the tube falls and remains fixed at a level about 66 centimeter above the surface of mercury in the dish. Standard sea level pressure 66 centimeter on this scale. Since 1910, the millibars have gradually come into use as convenient unit of atmospheric pressure. It represents a force of 1000 dyne acting on 1 centimeter square. The SI unit of pressure is Pascal, that is equivalent to force of 1 Newton per square meter. The value of mean sea level is 1013.25 millibar at a temperature 15 degree centigrade and latitude of 45 degree. Thus, 76 centimeter of mercurial column is equivalent to 1013.25 MB. Isobars are imaginary lines drawn on a weather map connecting point of equal pressure. Now let us study the latitudinal distribution of atmospheric pressure. It is also known as horizontal distribution of atmospheric pressure. It is characteristic by low and high pressure belt. There are mainly seven pressure belts on the earth. The formation of these pressure belts are either due to thermal factor or rotational factor. Thermal factor operates due to the differential heating of the surface of earth and the atmosphere. Equatorial low pressure belt and polar high pressure belt, on the other hand, due to the effect of radiation rotation of Earth, some pressure belts are dynamically induced. Subtropical high pressure belt and subpolar low pressure belts. You would understand this by studying all the pressure belts in detail. There are seven alternate belts of low and high pressure on the Earth's surface. They are listed below: equatorial low pressure belt, subtropical high pressure belt, subtropical that is for northern hemisphere, then subtropical high pressure belt for southern hemisphere, subpolar and low pressure belt for northern hemisphere, subpolar low pressure belt for southern hemisphere, polar high pressure belt northern hemisphere, and polar high pressure belt southern hemisphere. First A, the equatorial low pressure belt. The pressure belt is located in the vicinity of the equator between 5 degree north and 5 degree south latitude. The average pressure in this belt is less than 1013 millibar throughout. The equatorial toe of low pressure is the zone of convergence of trade wind blowing equatorwards from the subtropical belt of high pressure in the northern and southern hemisphere. Thus, northeast trade wind and southeast trade wind converge here to form intertropical convergence zone, that is ITCZ. The equatorial trough of low pressure is tied with the sun. Therefore, it shifts towards the north and south of the equator with the apparent movement of the sun. Then the subtropical high pressure belt. The subtropical high pressure belts are located between 20 latitude 25 degree to 35 degree in both the hemisphere. The most important features of this pressure belt is that it is broken into a number of high pressure centers or cells. In the northern hemisphere, it is called the North Subtropical High Pressure Belt, and in the southern hemisphere, it is called South Subtropical High Pressure Belt. The high pressure belt in this latitude is because of the settling down of winds that arose in the equatorial region and got deflected toward the pole due to the earth rotation. So these subtropical high pressure belt are dynamically induced and not thermally induced, in spite of the temperature being fairly high in these regions for a greater time of the year. These belts have a convergence zone at higher altitude which when subsides causes piling up of the air and reduction of the volume, thus resulting into high pressure. Thus, anticyclonic condition develop which results in calm and arid weather. In older days, vessels or ships with cargo of horses passing through these belts found difficulty in sailing under this calm condition. Hence, they were forced to throw the horses into the sea in order to make the vessels lighter. Therefore, these high pressure zones are also called as horse latitude. Contrary to the equatorial region, there are the regions of divergence of wind from ground level as winds blow from this belt towards the equatorial and subpolar low pressure belt. Then comes the subpolar low pressure belt. Subpolar low pressure belt are located below 60 to 70 degree latitude in both the hemisphere. These low pressure belts are also dynamically induced in spite of the fact that these regions experience low temperature throughout the year. Due to the rotation of Earth, the air develops a tendency of being thrown outward or spreading outwards. Winds from here are displaced towards subtropical high pressure and polar high pressure zone. As a result, low pressure belt develops here. In the southern hemisphere, there is an uninterrupted belt of low pressure between latitude 60 to 70 where there is a very vast expanse of ocean. The pressure belt is broken in the northern hemisphere due to the dominance of land, land masses here. However, there are well defined low pressure cells over the northern ocean. The cells of this low pressure system lies into the Aleutian Islands in the Pacific Ocean and between Greenland and Iceland in the Atlantic Ocean. Then comes the polar high pressure belt or polar highs. The polar region are characterized by low temperature throughout the year and hence high pressure persists as the poles which overcomes even the high cryolys effect in the region. In northern hemisphere, it is called North Polar High Pressure Belt, and southern hemisphere it is called South Polar High Pressure Belt. Winds from these belts flow towards the subpolar low pressure belt. Then the humidity and precipitation. Humidity refers to water vapor content of an air at a particular time or and place. Water is the most abundant substance found on the earth and covers about 70% of earth's surface, though it is very unevenly distributed. Also, a very small amount of fresh water is available for use through water appears everywhere on earth, and that is in the air, in land, and in living every living being. It also exists on the earth in all the three states, that is solid, liquid, and gaseous state. The different physical state of water is in fact very important as they are all connected to the hydrological cycle. The hydrological cycle. The hydrological cycle, also known as water cycle, is the continuous movement of water on and above below the surface of earth through physical process of evaporation, condensation, precipitation, infiltration, surface runoff, and subsurface flow. During the process, there is also change in form of water like solid ice, liquid and gas. What gas is the water vapor. The key phenomena in water cycle are evaporation, condensation, precipitation, runoff, sublimation, transpiration, and evapotranspiration. The process of conversion of liquid water to water vapor is called evaporation. The reverse of evaporation is called condensation, and that makes a change from gaseous to liquid state. Sometimes there is a direct change of state from solid ice to water vapor. This process is called sublimation. Reverse of sublimation is called deposition. Further changes of state from liquid to solid is called freezing. The change of state from the solid to liquid is called melting. The process of evaporation, sublimation, and melting consumes energy, while condensation, deposition, and freezing release energy. In strong sunlight, water evaporates from the ocean surface and other water bodies. This is taken to be the beginning of the hydrological cycle. The hydrological cycle gives the proportion between precipitation, evaporation, and runoff, which varies from continent to continent. Groundwater flows into the ocean, river, and stream, or it is goes back into the atmosphere through the evaporation from soil and transpiration from vegetation. Some of the water remains on the earth's surface as runoff, which flows into lake, river, and stream, and is carried back to the ocean, where the cycle begins once more. So here is the hydrological cycle. You can see directly how the groundwater flow and how the process of evaporation, precipitation, condensation, evaporation, and evapotranspiration, and the water body, the water going from the water body to the atmosphere and again coming back to the uh, uh, land and water bodies. That is the cycle, complete cycle. It is the hydrologic cycle. Precipitation and its forms. The kind of precipitation received by earth depends on the various temperature above the surface. The one is rain, then the snow, then sleet, then freezing rain, then hail, then drizzle. Rain is precipitation in liquid form. Also, higher altitudes or higher latitudes, rain may begin as snow. But if the air temperature near the surface is above freezing, the snow will melt into rain and fall in liquid form. Snow. Snow is precipitation in solid form. If the air temperature are below freezing, then precipitation will be in the form of snow. Then sleet. This occurs when the snow falling through a warm layer of air melts and passes through a cold layer of air. The water refreezes and falls in solid form as sleet. These are small pellet of ice with diameter about 5 millimeter or less. Then freezing rain. This occurs when the snow melts upon passing through a warm layer of air and then freezes on the surface whose temperature is at or below freezing. Then hail. Hail falls as large pellets or balls of ice having diameter from 5 to 50 millimeter. Hailstones form due to the up and down movement of moisture ladder air inside the cloud. Cloud droplet freezes when they reach temperature below 0 degree centigrade, then melts and then re-freezes once more, and the process goes as air goes up and down through the storm. Then diesel. Diesel are extremely minute droplet of water having diameter of about 0.5 mm or even less and falls continuously from low stratus clouds. However, the amount of water that has fallen is significantly low in this case. Then types of precipitation or rainfall. One is orographic precipitation. Then you have convectional precipitation. Then you have cyclonic precipitation. So these are three kind of precipitation, and they have shown it by the figure. So figure 1.4 shows the orographic precipitation. Then figure 5.5 shows the convectional precipitation. Then 5.6 shows the cyclonic precipitation. Then the water balance. The concept of water balance has recently gained considerable importance among the climatologist, meteorologist, geographer, geologist, hydrologist, and from other disciplines concerned primarily with water problem. Water balance may be defined as the income of water from precipitation and other sources, and the loss or outflow of water by means of evapotranspiration, which represents the combined loss of water from the earth by means of evaporation and transpiration, as well as from other sources. In other words, the process of evapotranspiration is actually the reversal of the process of precipitation. The water balance can be shown using the formula P equal to Q plus E plus AS, where P is the precipitation, E is the evapotranspiration, AS is the change in storage. So element of climate are basically the primary conditions of atmosphere, which include wind, temperature, pressure, humidity, cloud and precipitation. However, the intensity and the distribution of these elements function as controls of weather and climate. Sun is the prime source of energy for Earth. Insolation is defined as the incoming solar radiation. It is interesting that there exists a perfect balance between the amount of incoming solar radiation and the outgoing terrestrial radiation, which is also called the Earth radiation balance. Insolation is more in equatorial region and it declines polewards. Isotherms show the horizontal distribution of temperature on Earth. Since air has weight, it exerts pressure. Air pressure is defined as total weight of the mass of column of air above per unit of area at sea level. Standard sea level pressure is 76 centimeter on a barometer, which is measures the atmospheric pressure. SI unit of pressure is Pascal, that is equivalent to the force of 1 Newton per square meter. The value of mean sea level is 1013.25 millibar at temperature of 15 degree centigrade and latitude of 45 degree. There are mainly seven pressure belts on the earth which are formed either due to thermal factor or rotational factor. Then we discussed here the humidity, the precipitation, then the water balance. So this is the completion of the unit 1. Then we will go to the unit 6. So unit 5 is over, then unit 6, weather phenomena. In the previous unit of this book, you have all been introduced the element of climate and their control. So now you are aware that there is a differential heating of a different part of the earth due to the incoming solar radiation. This brings about differences in the temperature, pressure, and rainfall, etc., and in fact different climatic conditions across the globe. In this unit, we are concentrating more on weather phenomena or disturbances. You have already been introduced to weather and climate in the previous unit. In this unit, you will get a short introduction to weather. To understand different weather phenomena, we need to get an overview of different air masses. Meeting of the different air masses leads to development of fronts in fact cyclones. You will also study about tropical cyclones which are non-frontal cyclone and about jet streams and monsoons. Weather and introduction. Let us have a quick recap about weather. Weather refers to the state of atmosphere at any given time and denotes the short-term variations of atmosphere in terms of temperature, pressure, wind, moisture, cloudiness, precipitation, and visibility. These are also known as the element of weather. Weather is highly variable. It varies not only from day to day or even hour to hour. This is because of the constant change in the element of weather which are closely interrelated. Take for example, if temperature rises, pressure becomes low, wind gets attracted towards the low pressure area, gives rise to convection current, and results in cloudiness, low visibility, and precipitation. Extremes of these conditions may lead to cyclone or other weather disturbances. It is important to note that most of the weather phenomena occur in the lowest level of the atmosphere, that is the troposphere, just below the stratosphere. Introduction to air masses. As mentioned earlier, in order to understand the atmospheric disturbances, we need a clear understanding of the air masses. This is because air masses play a major role in bringing about day to day weather changes and producing different climate types in the long run. So, let us learn about the air masses. An air mass is an immense body of air, usually 1600 km or more across and perhaps several kilometers thick, which is characterized by homogeneous physical property, particularly temperature and moisture at any given altitude. We can conclude that air mass is a large body of air whose physical properties, especially temperature, moisture content, and the lapse rate, are more or less uniform horizontally for hundreds of kilometers. Classification of air masses. There are three bases of classification of air masses. These are thermal, latitudinal, and configurational. On the basis of temperature, air masses can be broadly be divided into warm air mass and cold air mass. On the basis of latitudinal extent, it may be tropical and polar air mass, and on the basis of configuration, they can be continental air mass or maritime air mass. Again, composite scheme may be given by combining all the three above-mentioned schemes. Composite scheme known shows that there are two major types, four secondary order types and eight third order types. Each one is again divided on the basis of stability. Altogether, it becomes 16 type of air masses. So here it has been shown here. Air masses are two types, polar and tropical. Polar again divided into continental and maritime. Tropical divided into continental and tropical and maritime tropical. Then continental polar divided into continental polar cold, continental polar warm. Similarly, maritime polar divided into maritime polar cold and maritime polar cold. Then continental tropical also divided into two types. Then maritime tropical also divided into two types. These are the classification of air masses. Then continental polar air mass. This air mass brings a lot of meteorological changes. It becomes more effective during the winter season in northern USA and Canadian column of air mass and also Siberian air mass. Siberian air mass is formed due to the shift pressure belt and very low temperature prevailing over the region. Subpolar low pressure belt disappears from the Siberian plateau, and one of the largest column of air mass is formed in Eurasia, which is called Siberian air mass. All these air masses promote polar cold winds, which modify the meteorological condition of the area visited by them. Then you have maritime polar air mass. The air mass prevails over the northern part of North Atlantic and Arctic Sea region. During winter, both are in continuity and are responsible for the development of cold front and temperate cyclone as they move southwards. Visiting areas receive very cold condition, but the moving air is also modified while moving towards the lower latitude. However, due to the low temperature, sometimes it brings snowfall even in coastal areas of Western Europe. Then the continental tropical air mass. These air masses are characterized by moderate temperature, low moisture, and low humidity, and constitute the source of trade winds and westerlies. However, continental tropical has seasonal changes in regional perspective. Central plains of India develops these air masses only during winters. During summers, this zone becomes low pressure area, due to which continental tropical high pressure air mass in southern USA and southern China similar situation is formed. Then maritime tropical air mass. The air mass is principally the subtropical high pressure area of North Pacific and North Atlantic. Winds blowing from these sources have greater meteorological consistency as they move on the Earth's surface. These air masses also form the source of trade winds and westerlies. It leads to the condensation of lower atmosphere and fog appears and visibility decreases, and this is the reason why English Channel becomes permanently foggy due to this. Then fronts and temperate cyclones. As we have mentioned earlier, that air masses with contrasting physical properties like temperature, pressure, humidity, density, etc., come into contact with one another along a sloping boundary called front. So fronts are defined as the sloping boundary surface on the transitional zone between the two contrasting air masses. Fronts vary in thickness from 50 to 100 km. The boundary always slopes upward over the colder and denser air, exhibiting abrupt temperature discontinuous throughout the vertical extent. Since air masses are three-dimensional, so the boundaries separating two different air masses are also three-dimensional, as is having both vertical and horizontal extent, although in weather charts they are shown as lines. Systematic evolution of front in mid-latitude region due to the convergence of polar air mass and the warm subtropical air mass is known as frontogenesis. Frontogenesis is well explained by the polar front theory. The general atmospheric circulation favors divergence of air masses in subtropical and polar region, but there is convergence of two air masses of different properties in subpolar low pressure region, which gives rise to fronts and temperature cyclones. Let us now learn about cyclones and fronts in greater detail. The atmospheric disturbance which involve a closed circulation about a low pressure center anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere are all called cyclones. In simple word, movement of air at around a vortex or a depression or low pressure area is called cyclone. There are two types: extratropical cyclone and tropical cyclone. Extratropical cyclones are weather disturbance of temperate and high latitude regions. In common usage, they are also called temperate cyclones. According to the polar front theory, frontal activities or temperate cyclones passes through six stages which are explained as follows. First stage. In the initial stage, these two the two contrasting air masses move parallel to the front in opposite direction, maintaining their boundary zone for some time. The boundary at this stage is known as stationary front. Second stage. The second stage is called as the initial stage, which marks the beginning of cyclone circulation as the cold and the warm air masses penetrate into the territories of each other and thus a wave like front is formed. Then the third stage. This stage is the stage of evolution of warm sector. Now cold and warm fronts are clearly formed. The meeting point of the two fronts become the center of low pressure which around which cold and warm wind begin to circulate. Cold air advances equatorwards while the warm air advances polewards along the warm front. Now, isobars are almost circular. Then the fourth stage. During the fourth stage, cold air overtakes the warm air. Warm sector is further narrowed as cold air moves faster equatorwards. Then fifth stage. This is the stage of occlusion. Here cold front overtakes the warm front, pushing the warm air aloft and closing the warm sector. The area of low atmospheric pressure is thus filled up by the cold air and occlusion occurs. This new frontal surface is called occluded front. The depth of the cold air along the occluded front increases and the entire warm sector is forced to rise until it spreads out laterally over the cold air mass. Then the sixth stage. This is the stage of dissipation. The air fails to turn further and the opposite moving airs emerge between this stationary front is re-established. Refer to the figure 6.2 to understand better. So here this is the 6.2 figure, the stages of temperate cyclones. You can see the stationary front, the occlusion front, the warm front, the cold front, and the isobar and the precipitation. Then cold front. Cold front is that front along which cold air becomes active and invades the warm air territory. The cold air becomes denser, remains on the ground, but forcibly uplifts the warm air. Since air motion is retarded near the ground surface due to the friction, while the free air aloft has higher velocity, hence the cold front becomes much steeper than the warm front. Its slopes varies from 1 is to 50 to 1 is to 100. Here the clouds are generally cumulonimbus, which brings hailstorm in Europe and UK. Sometimes nimbostratus and stratocumulus clouds are formed over UK. Then the warm front. It is that gently sloping frontal surface along which warm air becomes active and rises slowly over the cold dense air. The average slope of warm front in the middle latitude varies 1 is to 100 to 1 is to 200. Then occlusion front. It is defined as the front formed when the cold front completely overtakes the warm front and displaces it from the ground. Occluded front is of two types, having different weather conditions. Stationary front, as the name suggests, surface position of the front does not move. Winds on either side of this front appears to be nearly parallel. Then the tropical cyclone. You were taught in the previous section that there are two types of cyclone, temperate cyclone and tropical cyclone. We discussed about the front and temperate cyclone there. Let us now study about the tropical cyclone in this section. Tropical cyclone emerges due to the thermal effect. Thermal effect is the emergence of the center of low pressure and warm air of almost similar properties begins to rush to the center. It emerges invariably over the surface of ocean between 8 degree to 15 degree latitude. Extensive shallow lows occasionally formed along with the thermal equator become cyclonic once the situation is beyond 8 degree latitude.
ସରି ସାର୍ ଟିକେ ଶୁଣିବେ? ହ୍ୟାଲୋ
ଆଜ୍ଞା ଆଜ୍ଞା
ସାର୍, ଆପଣ ଓଡ଼ିଆ ତ ଓଡ଼ିଆରେ କହିଲେ ବୁଝିବେ?
ଆଜ୍ଞା
ସାର୍ ଟିକେ ଇଲାବୋରେଟ୍ କରିକି ପଢ଼ାନ୍ତୁ, ଆପଣ ଖାଲି ରିଡ଼ିଂ କରୁଛନ୍ତି।
ଇଲାବୋରେଟ୍ କରିକି
ବି ତ
ପଢ଼େଇଲେ କ'ଣ
ରିଡ଼ିଂ
ସରିବ
କରିପାରିବେ, ଆପଣ
ପୁରା
ଟିକେ ଖାଲି
ପୁରା
ମାନେ ଏମିତି
ଏଇଟା?
କୁହନ୍ତୁ ପଏଣ୍ଟସ୍ ଗୁଡ଼ା ଯେମିତି ମନେ ବି ରହିବ। ଆପଣ ସାର୍ ଆପଣ ତ ପଢ଼ୁଛନ୍ତି ବହି, ଆମେ ବି ସାର୍ ପଢ଼ିପାରିବା। ଆପଣ ସାର୍
ଆଜ୍ଞା
ଟିକେ ପଢ଼େଇଲା ଭଳିଆ ପଢ଼ନ୍ତୁ। ଆପଣ ଖାଲି ଟିକେ ଟିକେ ପଏଣ୍ଟ ଗୁଡ଼ା କୁହନ୍ତୁ ଯେମିତି ମନେ ବି ରହିବ।
ମନେ ରହିବ।
ଆପଣ ଖାଲି ରିଡ଼ିଂ କରୁଛନ୍ତି, ମୁଁ ଅଧଘଣ୍ଟା ହେଲା ଅଛି ରିଡ଼ିଂ କରୁଛନ୍ତି ଖାଲି ଆପଣ।
ଦେଖନ୍ତୁ ପୁରା
ଟିକେ
ଯେତେବେଳେ
ସାର୍
ଆପଣ
ମଝିରେ ମଝିରେ
ଚାରିଟା
ପଜ୍
ୟୁନିଟ୍
ନେଇକି
ଗୋଟେ
ଟିକେ ବୁଝନ୍ତୁ।
କୁ ସାରିବେ, ବୁଝୁଛନ୍ତି ନା, ଚାରିଟା ୟୁନିଟ୍ ଆ ଭିତରେ ତ
ସାର୍
ସବୁଗୁଡ଼ା
ଚାପ୍ଟର
ଆପଣଙ୍କର।
ସରିଛି ସେମିତି, ଆପଣ ଚାପ୍ଟର ସାରିବା ଚକ୍କରରେ ଟିକେ ସାର୍
ଆଜ୍ଞା
ଶୁଣନ୍ତୁ, ସରି ଆପଣ ସାର୍ ଭୁଲ ବୁଝିବେନି।
ଆଜ୍ଞା
ଚାପ୍ଟର ସାରିବା ଚକ୍କରରେ ପିଲା ତ ବୁଝିପାରିନି, ଆପଣ ଖାଲି କଣ୍ଟିନ୍ୟୁ ରିଡ଼ିଂ କରି ଚାଲୁଛନ୍ତି, ଯୋଉଟା ଘରେ ବି କରିହବ। ଆପଣଙ୍କ କଥା ଶୁଣିଲା ଟିକେ ମନେ ରହୁଛି, ମାନେ ହଉଛି, ପାଠ ପ୍ରତି ଆଗ୍ରହ ଆସୁଛି, ଆପଣ ଟିକେ ବୁଝାନ୍ତୁ ସେଇଟା, ଯୋଉଟା ଟିକେ ମନେ ରଖିଲା ଭଳିଆ ପିଲାଙ୍କୁ ହବ ସେଇଟା ଟିକେ ବୁଝାନ୍ତୁ।
ଆଚ୍ଛା
ଆପଣ ଖାଲି ରିଡ଼ିଂ ମାରୁଛନ୍ତି। ଆଜ୍ଞା
ବୁଝିଲି। ସପୋଜ କରନ୍ତୁ ମୁଁ ଆପଣଙ୍କୁ କହିଲି ଏଇ ଲାଇନଟା, Thunderstorms are defined as storms produced by the clouds and they are always accompanied by lightning and thunder. Aku puଣି ମୁଁ ଆଜ୍ଞା ଆପଣଙ୍କୁ ବୁଝେଇବି କେମିତି ମୁଁ ବି ଜାଣିନି ଲାଇକ୍ ସାଇକ୍ଲୋନ୍ ଆପଣଙ୍କର ଯୋଉଟା ସବୁ ହାଇଲାଇଟ୍ କରିକି ସେ ଦେଇଛନ୍ତି ଯେମିତି ଥଣ୍ଡର ଷ୍ଟର୍ମ କ'ଣ ଟର୍ନାଡୋଜ କ'ଣ ୱାଟର ସ୍ପ୍ରାଉଟ୍ସ କ'ଣ ଏଇଟା ଗୋଟେ ଏକ୍ସାମ୍ପଲ୍ ଆପଣ ନେଇକି କହୁଛି ମୁଁ ତେଣୁ ଏଇଟାକୁ
ମୁଁ ସାର୍
ଆପଣଙ୍କୁ
ଆପଣ ସାର୍ କେମିତି ପାଠ ପଢେ ଆପଣ ଭଲସେ ଜାଣିଛନ୍ତି ଆପଣ ଖାଲି ରିଡିଂ କରନ୍ତୁନି ଖାଲି ସେଟା ସଜେସନ ଦଉଥିଲି ଯଦି ସାର୍ ଭୁଲ ହେଇଛି କ୍ଷମା କରିବେ କିନ୍ତୁ ଏଇଟା ହିଁ
ନା
ମୁଁ
ନା ନା
କହୁଥିଲି
ନା
ଆପଣ
ନା
କଣ୍ଟିନ୍ୟୁ
ମୁଁ
ରିଡିଂ
ଆପଣ ଯାହା
କରିଚାଲନ୍ତୁ।
କହୁଛି ମୁଁ ବୁଝିଲି ମୁଁ ଆପଣ ସେ କଥା କହୁନି ମୁଁ ଆପଣ ମାନେ we are discussing we are not arguing we are discussing ନା ମୁଁ ସେଇଟା
ଆଜ୍ଞା
କହୁଛି
ଆଜ୍ଞା
କୋଉଟା we are ହେଲେ ବେଟର ହବ I also accept that କିଛି ଅସୁବିଧା ନାହିଁ ଦେଖ
ପିଲା
I am a
ଅଛନ୍ତି ସାର୍
chemist
ପଚାରନ୍ତୁ ସମସ୍ତଙ୍କୁ କୋଉ ଭଳିଆ ବେଟର ହବ ଆଉ ଟିକେ ବୁଝେଇ କୁହନ୍ତୁ ବାକି କିଏ ବି କୋଉ ଷ୍ଟେଟ ରୁ ଥିବେ ଆମେ ଓଡିଆରେ କଥା ହଉଛୁ ବେଶୀ ସମୟ କଥା ହବାନି ଟିକେ ଦେଖନ୍ତୁ।
okay so what you suggest what is the better way that let me figure out because if I will prepare the slides and I will teach this then it will take more time and that is not possible for me कि ମୁଁ ଆପଣଙ୍କୁ ଗୋଟେ ଗୋଟେ ଜିନିଷ ଟୋଟାଲି ବୁଝେଇବି କି ଏଟା କ'ଣ କେମିତି ହଉଛି so because ହଁ ମାନେ ଆପଣ ବି ଯାହା କହୁଛନ୍ତି I can understand your point but the thing is that how to go about it anybody you want to give us some suggestions ଆଉ କିଏ ଅଛନ୍ତି କି
Sir, please go ahead.
ନା ମାନେ ମୁଁ ପଢିବା ଭଳି ପଢଉଛି ଯାହା ଲେଖା ହେଇଛି ମୁଁ ଆପଣଙ୍କୁ କହି ଦଉଛି କିନ୍ତୁ କଥା ହଉଛି କି ହ୍ୱାଟ ଏଭର ହି
ନାଇଁ
ସେଡ୍
ସାର୍
ଇଟ୍ ଇଜ ରାଇଟ୍
କଥା ତ ଆମେ ଡିଷ୍ଟାନ୍ସ ଲର୍ଣ୍ଣିଂ କରୁଛୁ ନା ଆମକୁ ତ ପଢିବାକୁ ବି ସେତିକି ଟାଇମ୍ ମିଳୁନି ଆପଣ ପଢୁଛନ୍ତି ଆମେ ଶୁଣୁଛୁ ସେତିକି ମନେ ରହୁଛି ବୁଝୁଛି ସେତିକି ଦରକାର ସାର୍
ନା ଆକ୍ଚୁଆଲି ମାନେ ମୁଁ ଯୋଉଟା ଆପଣ ମାନଙ୍କ ଟାଇମ ବି ନଉଛି ପ୍ଲସ୍ ମୋ ଟାଇମ ବି ଏଥିରେ ଯାଉଛି ଯଦି ଏଥିରେ କିଛି ଲାଭ ନ ହବ
ୟେସ୍ ସାର୍
ହଁ ଯଦି କିଛି ଲାଭ ନ ହବ ଇଟ୍ ଇଜ ନୋ ମିନିଂ
ନାଇଁ ସାର୍ ଲାଭ ହଉଛି ଆମେ ଶୁଣୁଛୁ ନା
ନା ତଥାପି ମାନେ
ପାଠଟା ତ ଆମେ ବହି ଖୋଲିକି ପଢି ପାରୁନୁ ନା କେତେବେଳେ କ୍ଲାସ୍ ବାହାନରେ ହିଁ ଶୁଣୁଛୁ ବୁଝୁଛୁ ସାର୍ ପ୍ଲିଜ୍ କଣ୍ଟିନ୍ୟୁ କରନ୍ତୁ
ଠିକ ଅଛି ମୁଁ ଦେଖୁଛି ତାପରେ ଦେଖିବା otherwise I will rethink tonight and I will let you know if there is some better way
Thank you, sir. Hey.
because it is such a huge subject and in order to finish this in a one day anyway we'll see so jet streams are defined as the swift geostrophic air streams in upper troposphere that meanders the relatively narrow belt these are thousands of kilometers in length and a few hundred kilometers in width and having the vertical thickness of two or more the mean velocity of jet stream is about 144 km per hour. However, at times, the mean velocity of inner core of jet streams may be as high as 480 km per hour. The regions around 30° north and the south of the equator and 50° to 60° north and south of the equator are areas where temperature changes are the greatest. As the difference in the temperature increases between the two locations, the strength of the wind increases. Therefore, the region around 30° north and 50° to ଆଜ୍ଞା ଗୋଟେ ମିନିଟ୍ So the 50° to 60° north-south region is there where the polar jet is located with the subtropical jet is located around 30° north. Jet streams vary in height of 4 to 8 miles and can reach speed of more than 442 km per hour. Jet streams play a significant role in determining the weather condition in lower atmosphere. The path followed by the temperate cyclones or mild latitude weather disturbances are largely controlled by this upper air circulation. Movement of jet streams is also important in determining the prolonged period of floods or drought. So we see that surface meteorological conditions are highly affected by the path of jet streams, and so a preliminary knowledge of jet streams is necessary for studying the weather phenomena. Jet streams also affect the regulatory of monsoonal winds. We will discuss in the next section of this unit. Then southwest and northeast monsoon. The term monsoon is derived from the Arabic word mousim, which means season. It refers to the seasonal or 6 monthly reversal of the direction of the wind. Monsoons predominantly occur in South Asia, Southeast Asia, part of the China and Japan. Other regions being the southern USA, northern Australia, and in western Africa. Monsoon winds have helped merchants and travelers who used to travel by boat for long distance in the Indian Ocean. Now let us study about the southwest monsoon and northeast monsoon, which marks the reversal of the wind direction and are also known as summer and winter monsoon. First is the southwest monsoon. During the summer, continental regions of Eurasia are heated up faster in comparison with the adjoining ocean. Hence, low pressure develops over the continents in the southern and southern-western Asia during summer. However, contrary to this, the oceanic areas are having relatively higher pressure. This pressure difference causes winds to blow from Indian Ocean to the continent. The southeast trade winds blowing in the southern hemisphere crosses the equator and gets deflected to the right due to the Coriolis effect and becomes southwest wind, which are moisture laden onshore winds and are in the fact southwest monsoon rainfall bearing winds. The southwest monsoon gets split into two branches due to Indian Peninsula, that is Bay of Bengal branch and Arabian Sea branch. These onshore moisture-laden winds bring heavy rainfall in the windward slopes. Take for example the Arabian Sea branch, which bring heavy rain along the western slope of Western Ghat. After crossing the windward slopes, they descend over the leeward eastern slope, which where they get warmed up adiabatically. So these areas are actually the rain shadow areas, as the amount of rain received here is quite low compared to the windward slopes. The branch continues its journey across the Indian peninsula, and some are even diverted towards north and reach Kutch, Rajasthan, and even Jammu and Kashmir. In the absence of any mountain barrier, these, however, do not bring any rain in Rajasthan. The Aravallis are parallel to the direction of these winds. This is the reason why Rajasthan is a desert. A current of Bay of Bengal branch moves towards the northeastern portion of India. There are the windward slope of eastern Himalaya receiving a heavy rainfall. A place called Mussoorie, along with the southern slope of Khasi Hills, receive the highest amount of rainfall in the world. The winds now turn due to Himalayas and reach the low pressure center of North India. Here the monsoonal wind blow from the southwestern direction and reaches up to the western and northwestern part of India via the Gangetic Plains. This is also marked by the decrease in the amount of rainfall from the east to west. Retreating monsoon. By the end of September and early October, the low pressure center in the northwestern part of the Indian subcontinent weakens and again shifts to the equatorial region. This marks the beginning of the retreat monsoon. Due to this, rainfall starts decreasing in the northern plain of the India, which almost end up by October. This retreat of the gradual nature as the southern part of the Indian peninsula receives rain from the retreating monsoon even after October. Karnataka and Tamil Nadu receives rain in October-November through retreating monsoon. The retreat continues till December and soon northeast monsoon is about to set in. Northeast monsoon. During winter, the interior of Asia becomes excessively cold, resulting in the development of the continental anticyclonic condition or high pressure area. At this time, temperature over the seas to the east and south Asia are relatively higher and consequently pressure is lower. As a result of this arrangement of pressure areas, the gradient is from the continent towards the ocean. Consequently, cold surface winds move out from Asia towards the surrounding seas. The winds blow from the northeast direction in southern Asia and hence called the northeast monsoon, which brings winter rain to the areas where there are onshore moisture laden winds. The southern part of India peninsula receives the rain from the northeast monsoons. The above explanation of the mechanism of monsoon is the classical theory or thermal concept of the origin and mechanism of monsoon, as it was thermally induced due to the differential heating and cooling of land and oceanic areas in different seasons. This concept was propounded by Halley in a memorial presented to the Royal Society in 1686. However, the above concept regarding the monsoon could not explain the erratic behavior of monsoons, as thermal heating and cooling of land and oceanic areas is consistent. So it suggests that there are some other factors too which affect the onset and the entire mechanism of monsoons. We need to discuss about them in brief here. According to Cotes 1, upper air warm and anticyclonic conditions developing over Tibetan plateau is closely related with the burst of monsoons. His observation was further validated by the MONEX studies conducted by joint efforts of India and Soviet Union in 1973. Tibet Plateau is an enormous block of about 4,000 meter high plateau which is 2,000 km in length and 600 to 1,000 km wide. So summertime heating of Tibet Plateau make it a massive heat source due to the which warm and anticyclonic condition emerge in the upper part of the plateau. At this time, subtropical jet stream disappears from the Indian subcontinent. The upper air anticyclonic condition in the plateau produced an easterly jet stream from its southern portion with the flow direction from east to west. These are known as tropical easterly jet. After sweeping the entire subcontinent, these easterly jet streams descend in the high pressure region of Indian Ocean, further intensifying the high pressure prevailing there. It is from this high pressure oceanic region that wind start blowing towards the thermally induced low pressure area as monsoon winds. So the strength of monsoon is dependent to a great extent on the meteorological condition prevailing over Tibet and the strength of tropical easterly jet stream. Then El Nino's southern oscillations, that is ENSO. El Nino is a warm ocean current of the Peruvian coast in South America, which brings heavy rain in the adjoining coastal region of South America. Due to El Nino, an entire low pressure region is created across Pacific Ocean and Indian Ocean. This weakens the high pressure region of Indian Ocean and tropical easterly jets. Thus, the source of region of the origin of the monsoon wind is weakened, hence, it affects the origin and mechanism of monsoon. Then the classification of climate by Koipen and Thornowhite. Climatic classification helps in the comprehending the multiplicity of atmospheric conditions in meaningful, organized, simple, and general terms in a way that large and diverse information is grouped into similar entities and different from other groups by specific attributes. Different approaches have been adopted by geographic for climatic classification. So here is the Köppen system of climatic classification. Precipitation of temperature, average temperature in the coldest month is 18 degrees centigrade or above. Then the moist every month has 6 centimeter precipitation or more, no dry season. This is the complete classification. The table is given here. So, in summary, we can say the weather refers to the state of atmosphere at any given time and denotes the short-term variation of atmosphere in terms of temperature, pressure, wind, moisture, cloudiness, precipitation, and visibility, which are known as the element of weather. An air mass is an immense body of air, usually 1600 km or more across and perhaps several kilometers thick, which is characterized by homogeneous physical properties at any given altitude. Air masses play a major role in bringing about day to day weather changes and in producing different climate type on in the long run. Fronts are defined as the sloping boundary surface on the and transitional zone between the two contrasting air masses. Convergence of the two air masses of different properties in subpolar low pressure region gives rise to fronts and temperature cyclones. According to the polar front theory, frontal activities or temperate cyclone passes through 6 stages, those we discussed. Then tropical cyclones emerge due to the thermal effect of invariably over the surface of ocean between 8 degree to 15 degree latitude. Thermal effect causes the emergence of the center of the low pressure and warm air of almost similar properties begin to rise to the center. Monsoon is derived from the Arabic word mausim, which means season. It refers to the seasonal or 6 month reversal of the direction of wind, which leads to the southwest northeast monsoon. Though monsoons are originated due to the thermal effect, but jet stream and El Nino also affect the mechanism of monsoons. Climatic classification help in the comprehending the multiplicity of atmospheric conditions in meaningful, organized, simple, and general terms in a way that large and diverse information is grouped into similar entities and are different from other groups by specific attributes. This brings to the end of the unit 6. We will take a 5 minutes break, then we will start unit 7. Okay, so we'll again start with this meteorology. So it has the composition of atmosphere, start, stratification of atmosphere, moisture variables, greenhouse effect, Earth radiation budget, atmospheric stability, thermodynamic diagram, T figure and mixing of height, etc. Composition of atmosphere. Now let us learn about the composition of atmosphere. Dry air near the surface of ground level up to several kilometers mainly comprises 78.08% nitrogen, 20.95% oxygen, and small amount of argon, carbon dioxide is present. Other constituents of air consist of noble gases like xenon, neon, krypton, helium are also present along with the other trace gases CH4, CO, N2O, HNO3, ammonia, etc. The air present in the atmosphere may also contain 0.1 to 5% water by volume with normal range of 1 to 3%. Stratification of atmosphere. Atmosphere is stratified on the basis of temperature density relationship, which are based on the interrelationship between physical and photochemical phenomena in the air. Atmosphere may be divided into following strata, that is troposphere, stratosphere, mesosphere, thermosphere. So the troposphere is the lowest layer of the atmosphere, which extends from sea level to altitude 10 to 16 kilometer. Stratosphere is the second lowest layer of Earth's surface atmosphere. This layer ranges from 10 to 50 kilometer. Mesosphere lies between stratosphere and thermosphere. It ranges from 50 to 85 kilometer. Then thermosphere is the thickest layer in the atmosphere, which extends from 80 kilometer and above. Then the definition of pressure, this we all know. Pressure is unit is Pascal or Newton per square meter. Pressure is equal to force per unit area. Then temperature, measure of the heat is known as temperature. In general form, heat means energy. So when more energy is there, the hotter the things get. From daily experiences, we observe that when you exercise hard, you become sweaty or hot. The reason behind is that we have used a lot of energy while exercising, which increases heat of the body. Then wind, climate and weather changes frequently. Therefore, to determine and control weather, wind plays an important role. Wind is the movement of air relative to the surface of the earth. Wind blows due to the difference in horizontal and vertical gradient of atmospheric pressure. Pressure can be the reason behind distribution of wind on the surface of earth. Humidity is the amount of atmosphere water vapor. Humidity can be expressed as relative humidity or dew point temperature. Water vapor is the vapor form of water. Water vapors are transparent gases. Naked eyes are not be able to see humidity but can see it while condensing back to the droplet of water. Moisture variable. In order to specify the humidity or amount of moisture in air, there are various variables. These are dew point temperature, saturation vapor pressure, relative humidity, specific humidity, mixing ratio, wet bulb temperature, vapor pressure, and saturating mixing point. And virtual temperature. At a given condition, pressure moist air density is same as dry air density. The density of warm air is least when than the cold air, and water vapor are less dense than the dry air. Therefore, the virtual temperature remains increased or equivalent to the actual temperature. It is noted that saturation mixing ratio increases tremendously with temperature or approximately doubles with successive rise of 10 degrees centigrade. For higher dew point, it is important to consider the initial temperature correction. Radiation from sunlight. Sunlight or the radiation of sun comprises the mixture of IR and UV radiation. UV rays comes in between infrared and ultraviolet radiation in electromagnetic spectrum. The speed of electromagnetic wave in vacuum is 3 into 10 to the power 8 meter per second. The energy radiated from the core of the sun is due to the fusion of reaction occur which eliminates high energy gamma radiation. As the gamma ray photons reaches the surface of the sun, they get absorbed by solar plasma and makes gamma radiation to re-emit a lower frequency. Electromagnetic radiation of a sun strike the atmosphere of Earth. Some part of this radiation get absorbed by the atmosphere while rest moves to the Earth's surface. Accordingly, the UV radiation of sun are absorbed. The ozone layer absorbs the UV radiation and re-emit as heat to warm up the stratosphere, while the rest of the radiation are radiated back to the outer space. Parallelly, the radiation which are not absorbed by the atmosphere strikes the surface of Earth to heat it up. Moreover, the greenhouse gases present in the atmosphere are also responsible for absorption and heating of the atmosphere. Solar constant. The solar constant, a measure of flux, is the amount of incoming solar electromagnetic radiation per unit area that would be incident on the plane perpendicular to the rays at a distance of one astronomical unit. Visible light and all solar radiations constitute to solar constant. The value of solar constant is approximately 1.366 kilowatt per square meter measured by the satellite. Then greenhouse effect. A natural process which makes the earth's surface warm is known as greenhouse effect. When radiation from the sun strikes the atmosphere of earth, greenhouse gases absorb and re-radiates some of the radiation while the rest are redirected back to the space. The energy absorbed by the atmosphere and surface of the earth maintains a temperature of 33 degrees centigrade warmer at earth, which makes life possible on earth. Step 1, solar energy strike earth surface, some radiation get reflected back to the space. Step 2, the remaining solar radiation are absorbed by ocean and land to heat up the earth. Step 3, heat and radiates towards the space from earth. The green step 4, greenhouse gases trap some of the radiation in the earth atmosphere to sustain life. Step 5, anthropogenic activity like land cleaning, fossil fuel burning, and agriculture results in increment of GHG in atmosphere. Due to the extreme heat trapping by the greenhouse gases results in the rise in earth temperature. Greenhouse gases. These are various greenhouse gases present in the atmosphere. The main gases are nitrous oxide, carbon dioxide, methane, and water vapor. All these gases are made up of three or more atoms, and these atoms are loosely bound to one another, hence, on absorption of heat, get liberated. These vibrating molecules tend to release radiation, which further gets absorbed by another greenhouse gas molecule. This is the reason behind the heat near the surface of the earth. Some of the common greenhouse gases are carbon dioxide, methane, then earth radiation budget. You must be aware of financial budget that includes balancing of incoming and outgoing money. Similarly, if energy from the sun is earth income, while the energy that escapes from the earth to space is earth spending. If incoming radiation of sun will increase, then the earth would heat up. Due to the extra heat, due to the extra heat, the earth can emit long wave radiation. Alternatively, if incoming solar radiation is decreased, the earth is likely to be cool. Hence, all the solar radiation are not radiated back to the space. Some of these radiations get trapped by the greenhouse gases, which while some are stored in the ocean and ground. Atmospheric stability. Atmospheric stability governs that whether the air will increase or not. Moreover, it causes clear skies, storms, or sinks, or may do nothing. Stability depends on dry saturated adiabatic lapses rate and the environmental lapses rate. Therefore, to determine the atmospheric stability condition, we can compare the ELR and the DLR and SALR. Stability form. So stability, these are a specific stability condition and absolute stability. A condition is said to be absolute stability when both partial plots are in the same ELR side. So this is the diagram, they have shown it here, where the diagrammatic illustration of absolute stability, absolute instability, conditional stability, wet neutral, dry neutral, and external stability. They have discussed it here. Then diffusion. Diffusion is a physical process that refers to the net movement of molecule from a region of high concentration to one of lower concentration. Diffusion material can be any gas, solid or liquid, and diffusion solid or liquid, and diffusion can occur from within these three states. The important characteristic of diffusion is the movement along the concentration gradient. Factors affecting diffusion. There are various factors which affect the rate of diffusion. They are temperature, area of interaction, size of the particle, and concentration gradient. Then type of diffusion. Type of diffusion is simple. A simple diffusion is merely the movement of molecule along their concentration gradient without the direct involvement of any other molecule. Then facilitated diffusion, requires the presence of another molecule in order to diffusion to occur. Then adiabatic and inotropic process. Lapse rate the atmospheric variation in temperature in lieu with height. For instance, there is 6 degree centigrade temperature drop down with every kilometer depending on the location. The concentration of atmosphere water vapor determines the value of lapse rate. Dry adiabatic lapse rate means that the air cools at 10 degrees centigrade at every kilometer distance. However, moist adiabatic lapse rate is the cooling of air at below 6 degree for every kilometer. Adiabatic means that no external energy is involved in air cooling or warming. Then enthalpy and entropy. Enthalpy, the study of relationship between heat energy and work, is defined as thermodynamics. One of the main parameter in thermodynamics is enthalpy. Enthalpy is the content of heat in a system, and enthalpy is change in the heat which enters and leaves the system during a reaction. The occurrence of any given reaction depends upon if there is an increase in enthalpy of the system, means when energy released it is being added or decreased. The phrases internal enthalpy or the enthalpy of the system are two phrases with similar meaning. Likewise, the phrases external enthalpy or enthalpy of the surrounding refers to the energy of these molecules which are not involved in the reaction. To summarize, enthalpy is referred to the heat content of the system. In a reaction, change in enthalpy is approximately equal to the heat evolved and generated while a reaction is occurring. During a reaction, when a system releases energy, its energy content decreases and it has less energy with it. Then entropy is the measure of thermal energy per unit of temperature of a system which is not available for any useful work. Entropy is also considered as the randomness of the system. Changes in the spontaneous direction can be measured by entropy. Characteristic of entropy of universe is spontaneous process increases. As mass increases, entropy also increases. When liquid and solid dissolve in water, entropy of the system increases. gas dissociation in water leads to the decrease in entropy. Sorry, gas dissolution in water leads to the decrease in entropy. Brittle and hard substances have low entropy. Chemical complexity increases the entropy. So this brings to the end of the block 3, or you can say here the unit 6 7. So 5 6 7 is over. Then the unit 8, it is about the hydrometeorology and climate. So hydrometeorology network and catchment morphology. India being a developing economy must focus on the conserving all important resources, especially water. Effective water management leads to reduction in cost and energy required for the treatment. For water management, hydrologist planners mostly lay stress on the river as they are the source of fresh water along with groundwater. So gaining record of river flow helps in better flood risk estimation and hydropower generation. It also helps in hydrologists to quantify processes like precipitation that are acting upon the catchment area. Thus, hydrometric monitoring from the basis of the framing and operation of policies that assist in the making of decisions regarding growing of river gauging network. It is important to have a designated design of hydrometric network in place if proper hydrometric monitoring is to be carried out. Important definition: hydrometry, the measurement of study of component of hydrological cycle such as groundwater, surface water, rainfall, flow components such as discharge and viscosity and associated water quality. Hydrometric network: hydrological or hydrometric network is a set of gauges, scales, or stations that are used to collect data for different component of hydrological cycle. Hydrometric station: it is the cross section of the river where gauges are set up to measure the water surface level and flow of river. And catchment: it is an area on the land surface across which water flows as a stream and ultimately flows out through a single outlet point. Catchment morphology means consideration of physical characteristics of characters of the catchments such as topography, vegetation, soil, climate, and human effect apart from the water content of the catchment. Components of the hydrometric or hydrological network design. A hydrometric network is composed of river gauging stations fixed in a river basin for measurement of depth and discharge of river. These networks are source of hydrological data that is required for planning, design, and management of river water system. Hydrology. It is the branch of geophysics dealing with all elements of the hydrological cycle, such as distribution, property of circulation. It widely covers all the process that occurs on over the inside the earth surface in vapor, liquid, and solid state. Hydrology is the stepping stone for building hydrometric network and socio-economic analysis. Without the interest of the policymaker and the society, a hydrological network can neither be created nor can it be function. Policymakers should invest construction of a network by understanding its importance. There is a need to analyze how the network would benefit the society by creation of employment opportunities and would protect them in case of flood and drought by provision of timely forecast. Then optimization theory, it is also known as operation research and is composed of algorithms based on a set of decision variables such as number of gauges and their observation frequency that apparently contribute to come to a logical conclusion for a hydrological problem. Probability, and though research pertaining to hydrology is abundant in nature, some uncertainty still prevail in the specific area of flood forecasting. For these areas, hydrologists are probability to evaluate the return frequency of flood by monitoring the data for about 100 years. Then sampling theory. Different samples of data are collected for each parameter, and these might be some difference in the data point obtained. In order to quantify this difference, hydrologists use a set of equations derived from the concept of sampling theory. Correlation and regression analysis. Correlation is a statistical technique that checks the linear relationship occurring between two or more variables. If the magnitude of the correlation coefficient comes out to be 1 or minus 1, it shows a perfect linear relationship between the variables. If the magnitude is 0, it indicates no linear relationship. Regression analysis is used for determining the parameter of a relation. For example, if one needs to relate the data at one meteorological station with another, regression can be used. Then Bayesian analysis. Approach relies on the principle of probability, but in case of hydrometric network design, is used to estimate the variance in the sampling theory or the correlation coefficient, as both of these parameters are not known with certainty. Impact of climate change on hydrology and importance of hydrometric network. There have been several reports on impact of climate change on water resource sector. Climate change and its effect have been more phenomenal since the onset of last century. It has also been predicted that because of this phenomena, there would be greater shift in the seasonality of stream flows, leading to more floods and precipitation. It is a well-known fact that climate change has led to varied distribution of rainfall over the river basin, causing a further change in the flow regime of the river. Thus, it is important to design a precise hydrometric network to ensure generation of early flood warnings and focused conduction of drought mitigation programs. Moreover, in order to understand the cyclic patterns of stream flow, rainfall distribution, and ground study of groundwater, we need to the help of well-designed hydrometric network. Then precipitation. Precipitation can be defined as the formation of any tiny water droplet due to the condensation of atmospheric water vapor, which then falls under the gravity in different forms. Some form of precipitation are drizzles, rain, snow, and hail. Form of precipitation: liquid precipitation, frozen precipitation. Liquid precipitation is drizzle and rain. Frozen precipitation is snow, snow grain, ice crystal, sleet, hail, and snow pellet. Occurrence of precipitation, there are different processes. There is Wagner-Bergner Feinstein process. Then types of precipitation, it is rain. Already we have discussed in the last block that it is rain, then convective rainfall, then orographic rainfall, then cyclonic rainfall, snow, sleet, freezing rain, hail. Measurement of precipitation, it is liquid precipitation and solid precipitation. Then evaporation and evapotranspiration. Evaporation is known as the process by which water converts into liquid state to a gaseous water from a liquid state into a gaseous or vapor state. In atmospheric term, it is known as the motion of water molecule from various water bodies to the surrounding unsaturated air. Evaporation is the major pathway of the water cycle through which water moves from the liquid state back into the atmosphere as a water vapor. It is estimated that about 600 calories are required to convert 1 gram of water to vapor state. All the environmental factors mentioned in the above figure affect the rate of evaporation. So rate of evaporation depends on air pressure, humidity, wind speed, area of water surface, amount of water available, temperature, and salinity of water. Then evapotranspiration. Evapotranspiration is the integrated process of surface water evaporation, soil moisture evaporation, and transpiration of water from the plant's aerial part. It is the outpouring step of the water cycle and plays a major role in the management of Earth's water budget. Components of the ecosystem that contribute to the evapotranspiration are known as evapotranspirators, and the rate of evaporation is usually expressed in millimeters per unit time. Process of evapotranspiration is given in the figure here. Type of evapotranspiration: potential evapotranspiration, that is the PET, then actual evapotranspiration, then the factors affecting evapotranspiration: environmental factor, plant and crops, soil, and geographical. So environmental factors are temperature, humidity, wind speed, water availability. Then the plant and the crops are vegetative cover, plant height, leaf area index, leaf shape, reflectivity of leaves. Then soil is heat capacity, soil chemistry, moisture content, depth of water table, soil capillary. Then the geographical factor, that is the latitude, climate, amount of incident, and solar radiation. So you can read these different factors given here. Then soil moisture. Soil moisture scientifically is the water that lies between the water table. This is also known as unsaturated zone. This zone is further divided into three subzones as shown in the figure, that is the capillary, fringe zone, intermediate zone, and soil zone. Estimation of soil moisture. The component of soil moisture is generally small in comparison to other components of the water cycle. Nevertheless, it is of primary importance to many hydrological, biological, and biogeochemical phenomena. It plays an important role in controlling the exchange of water and heat between the land surface and the atmosphere through evaporation and transpiration. Consequently, it is an important factor for the development of weather pattern and precipitation. Information related to the soil moisture used can be used for watershed management, early warning of drought, and prediction of crop yield. Watershed structure can be built on soils to improve the infiltration, thereby increasing the soil moisture. However, there should be optimum doses of moisture present in the soil depending on the crop zone. More or less amount of moisture can result in fewer yield. Estimation of soil moisture can be done by direct method and gravimetric method. The direct method is gravimetric method. Then you have indirect method. So two methods are there in order to calculate the moisture content. The moisture content by the gravimetric method can be analyzed as moisture content on wet basis equal to wet minus dry wet and divided by dry wet into 100. Then river, lake, and groundwater. So water are in the form, rivers are the water bodies that originate from the mountain, flow towards the terrains, and ultimately end up joining the ocean. The classification of the river on the basis of topography, that is a river in hills, river in alluvial plains or flood plains, then tidal rivers. So based on the flood hydrograph, there is Flashie rivers and Virgin rivers. Then the Indian classification, this is Himalayan river and non-Himalayan rivers. So different the rivers are divided into different types depending on the Indian classification based on the flood hydrograph and based on the topography. Then similarly, you have lakes. According to the limnology study of lakes, lakes are generally divided into three zones: the littoral zone, the limnetic or pelagic zone, then the bentolic zone. So the lakes are also divided into classification of lakes. Classification of lake based on the mode of origin, based on the thermal stratification, and based on the riches in the nutrients. So lakes are divided into different types. These you can read these things. Then groundwater. While lakes are a surface water source, groundwater is the reserved subsurface water that occurs beneath the water table in soil and various geological formation that are fully saturated. These saturated formations are known as aquifers. Though these aquifers we can trap groundwater. Type of groundwater that connect water, fossil water, then jubilant water, then meteoric water, then rejuvenated water. Okay, so we will stop this much for today. Then again we will start tomorrow.